Okay, in this section we're going to talk about vectors, which hopefully you've seen a little bit about in physics. It's a really interesting unit because it's something that you can really visualize, and I've always really enjoyed talking about vectors and working with vectors. Firstly, what is a vector? A vector is basically a ray or a line with an arrow at the end of it that gives the magnitude and the direction of an object moving. So the length of the line, this determines the magnitude of the vector. That's the actual amount of force that's applied to the vector. Then the direction, the way the vector is moving, obviously indicates the direction. So, an example is the flight path of an airplane. This airplane followed the blue vector as it was climbing, and it was going, a decent speed. And then when it levels off and it starts going horizontally, it slows down a little bit. Do you see that? How the magnitude of the vector, horizontal vector, is shorter than the magnitude of the vector at an angle, because when an airplane plateaus off, it doesn't have to go as fast. Okay, so basically any vector has to contain 2 points, a initial point and an end point, which actually this is an actual line that has 2 arrows on the end of it. And then we've got a line segment here, and then we've got a vector here. This is the actual vector. The initial point is the point where the vector starts, and the terminal point is the point where the arrow is, the point in the direction at which the vector is moving. Okay, so any vector out in space is labeled by its magnitude and its direction. The position in space of the vector doesn't really matter. So do you see that all 3 of these vectors are going in the same direction and they all have the same magnitude or the same length? That means these vectors are all equivalent. It doesn't matter where they are in space. It matters the direction they're going in and their magnitude. When you refer to a vector, you can name it. A lot of times vectors are named as V and W. So this vector, PQ, right here, we can call this vector V. We could call this vector W. V and W are equivalent vectors. Okay, so if you want to add 2 vectors together, what you do, since it doesn't matter where they are in space, you can move those vectors around. If you have the vector V and W and you want to add them together, you line them up to where the terminal point of V lines up to the initial point of W. So you just you draw V, and where V ends, you start W. And then you draw a separate vector from the initial point of V to the terminal point of W, and that gives you V plus W when you add them together. So do you see that this V plus W vector has a much larger magnitude, and its direction is going in the same general direction as V and W? So here's an example. Vector addition is commutative. It doesn't matter whether you add V and W or W and V together. Do you see that? You'll get the same thing. It's also associative. Just like you'll find that vectors follow all the same basic rules of algebra, so they're actually pretty easy to work with. Okay, this is just the identity property. Oops, didn't mean to skip that so quickly. But basically, positive V is going to go in one direction. Negative V is going to be the exact same vector, but the terminal point and the initial point change values. So a negative vector is basically the same vector, just going in the exact opposite direction. So when you add a positive and a negative vector of the same magnitude, you get 0. Oh, I missed something. And then subtracting vectors. The simplest way I've come up with to subtract vectors is to just basically apply a -1 to the second vector and add them. You can see here that if you want to say V minus W, you can draw V and draw W. and then you can draw a resultant vector v minus w going in this direction, but I think that's too much to memorize. If you just have v, if you have two vectors v and w and you want to subtract them, the way I do this is I just go ahead and write v, draw v, and then I take w and I just make it negative. Since w in this case is pointing to the right, I'm going to draw it pointing to the left. And I'm going to add them together and then just use the same property that I use with addition and subtraction. And I will find that, so this would be negative w, v, that this is going to be v minus w here. Okay, so the next thing we're going to talk about is scalar multiplication of vectors. Again, it's very intuitive, very basic. If you have a vector v and you're asked to find 2v, you're just going to multiply both the x values and the y values by 2. So do you see if we have the vector v here, we need to move, our vector v has 1, 2, we move 3 units left and 1, 2 units up to get the terminal point. So 2v, we're going to have to move 6 units left and 4 units up. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4 to get the terminal point. So it's just basically stretched by a factor of 2. Negative v, just like I talked about before, is just the exact same vector in the opposite, moving in the opposite direction. So on the prep quiz, you may be asked to do a problem similar to one of these. If you're asked to graph the following vectors, v minus w, all you're going to do is do what we just talked about. Line the terminal points, our initial points, up with the terminal points of each problem, and you'll quickly see. So if we want to find v minus w, we take v, and then we take w, and we want to make it negative, so we make it go in the opposite direction, and line up the terminal point of v to the initial point of w, and you can add those together and you get v minus w. 2v plus 3w, what we have to do is take v, multiply it by 2, so that's why this is longer. Then we have to take w, multiply that by 3, that's why this is longer, and add them together. You get 2v plus 3w. Then lastly, 2v minus w plus u, same kind of thing, it's just a little bit more complicated, but you'll see, just looking at this, that they just line the points up. It's pretty straightforward, and it really helps to have grid paper, so make sure you print off some grid paper if you don't already have any, because it makes it a whole lot easier to work these problems out. Okay, the next thing you'll see in this section is AI plus BJ form. This is another way to label vectors, and you'll see that this is also very intuitive once you get used to it. Whenever you're labeling a vector, you're going to refer to its length along the x-axis with I. I is just going to be a label that you put on any vector that when you're referring to its displacement on the x-axis. J is the label you put when you're referring to the displacement along the y-axis. So for example, if you have a vector here with initial point P, terminal point Q, initial points at 0, 0, and terminal points at 5, 7, and we want to label this in terms of AI plus BJ, I, remember, is the displacement on the x-axis. So do you see how we go from 0 to 5 on the x-axis? So this is going to be 5I plus, and we go from 0 to 7 on the j-axis. So 5I plus 7j. That's how you label a vector like this. Remember, where it is on the coordinate plane doesn't really matter. It's more about its displacement. So if you have a vector like this that's not necessarily got a terminal point or an initial point at the origin, to figure out what this value is going to be, you just subtract 4 minus 1 to get your j value, which is going to be 3j, and to get your I value, you're going to say 4 minus 7. You're going to get, what is that, negative 3? So this position vector is going to be negative 3i plus 3j. And lastly, what we're going to talk about real quick is magnitude. Anytime you see a vector that looks like this, or a symbol that looks like this just refers to what is the actual magnitude of the vector. They're not worried about direction at all. They're just worried about magnitude. How big is the vector? How strong is the force? How fast is it going? So, for example, if you have a problem that looks like this, it says if the magnitude of a vector is 3, what is the magnitude of negative 3 times a vector? So basically, you just use scalar multiplication. You would just say negative 3 times 3, because v is 3, and you get negative 9. Okay, so you get negative 9, but remember, this is a magnitude. And so they're not concerned with the direction. The negative refers to the direction. So, the magnitude of this, strictly, I can't write, the magnitude is 9, is positive 9. The negative refers to the direction. It will be going in the opposite direction, but when you're asked for magnitude, you're asked strictly for magnitude. So I hope listening to this video helps you work through some of these problems. The last problem is one that I'm going to leave for you to try to figure out on your own. I know you can do it. It's pretty simple, but good luck with the prep quiz, and I'll see you on Tuesday.